Hey guys, we're going to jump into our big chapter on trigonometry, and today we're going to warm up with a discussion on angles. How do we measure those angles? Typically, we measure them in degrees, but we're going to kind of graduate to measuring them in radian measure instead of degrees as we get more and more comfortable with these. So what we're going to see today is we're going to focus on taking an angle. Like this one's in radians, 2 pi over 3. We're going to convert it to degrees, or we may do the opposite of that. And we're also going to do a lot of drawing and just making sure we can visualize and we feel comfortable seeing these graphs in action or these angles in action. So as far as when we start talking about degrees, we're always going to assume that our angles start right here. So this would be 0 degrees right here. That they didn't open up at all. And then as we start to open counterclockwise, this would be considered 30 degrees right here. The next one would be 45. And as we go around the horn here, this would be 60. And then if we go straight up, we've got, you could see this 90-degree angle, so we're at 90 degrees. We keep going around the horn here. Let's see, we've got 120, 135, 150. These are all very, very special angles here. 2, 2, 2, 2, 2. Oh, this is getting not my best drawing ever. And we get to 180 right here. So that's a semicircle. Let's see if we keep going here. We've got 210, 225, 240. So we got 210. Because it's really, you're taking the 180, you're adding an extra 30 degrees to it till you get to 210. We said we've got that 225. We've got the 240. We get down here to 270. And then we'll finish it up here with 300, 315, and 330. And then when we get back to the beginning, we're at a full revolution of 360. So those are like the really popular big angles we're going to talk about. Now, a lot of these angles fall within a specific quadrant. So all of my pink angles are what we consider quadrant 1. All the green ones are quadrant 2. All of those purple ones are going to be quadrant 3. And then these dark red ones are going to be quadrant 4. We use Roman numerals. And then you've got these strange birds like the 0, the 90, the 180, the 270, and then back to the 360. Those do not fall within a specific quadrant. Those are what we call quadrantal angles. Okay, so again, just practicing visualizing and drawing these angles. What if I made 1/12 of a revolution? So imagine you just ordered this pizza, you open it up, and it smells amazing, and you can't wait to bite into it. And you open that box, and they forgot to cut it. And so let's imagine that we cut that pizza into 12 congruent equal slices. And what you're getting at is, let's say we start the slice right there. If we cut it into 12 slices, we'd get 1 there, 2, 3, whoopsie. So, and then you'd basically get 3 in every quadrant for a total of 4. So that if we made 1/12 of a revolution, that would put us right here. And let's say 1/12 multiplied by 360 is going to make 30 degrees. So that's going to be right there. What if I made 1/8 of a revolution? And for all of these, I go back to the analogy of cutting that pizza, in this case, into 8 slices. So maybe we do the math part first. Maybe we do, oh, geez, I don't know if this color is going to show up. We'll try it. Yeah, that's not bad. 1/8 times 360. What does that make? That's going to make a 45-degree angle. And I think you guys would agree that, okay, if that's my first slice right there, I'm basically going to fit 2 slices in every quadrant for a grand total of 8 slices overall. Okay, what if I made 1/6 of a revolution? 1/6 of 360 is 60. So we're saying, okay, right here, there's 1 slice right there, that's 60. There's 2 slices, there's 3 slices, there's 4 slices, there's 5, and then back to 6. So we get 6 slices. 1/4 of a revolution is going to make 90. So yeah, 4 slices. Everybody's really hungry. We're just going to cut these into monster slices. There's your 1 slice right there, 90 degrees. All right. What if I made 1/3 of a revolution? So visualizing 1/3 of a revolution, let's see, that's going to make 120 degrees. So, oh my gosh, look at this slice. I don't think I've ever had a slice that big right there. So that's 1/3 of a revolution, and then 240 would, And then so you can see how it comes into 3 slices. Half of a revolution is just going to be that 180. We're going straight across right there. Here's a fun one. What's 2/3 of a revolution? 2/3 is going to make, let's see, 240, I believe, doing that in my head. So that's going to put you right here. So this rotation right there would be 2/3 of a revolution. Definitely you can see it's bigger than half, but not quite 3/4. Speaking of 3/4, 3/4 of a revolution would put you at 270. So that's going to say if we start here, we're going to go all the way to here. So we're going around the horn that way. 7/8. How about that for a funny one? 7/8 of a revolution is going to make 315, I believe. So that's going to put you right. Whoops, I missed the mark right there. So this would be, certainly bigger than 3/4, but not quite a full revolution. Let's see. And then, of course, 1 revolution would be 360, and that is the definition of going all the way around the horn. All right, so we got that out of the way. Definition of a radian. And a lot of times, if we were sitting in a classroom together, we'd use that analogy of, using a piece of string to measure the radius and then lining it very carefully along the outer perimeter here. But all we're saying is this distance right here is equal to the radius. This distance right here is equal. Okay, so if we used a shoestring to measure this guy and then a shoestring to measure this guy, these strings would be congruent. So the definition of 1 radian is the measure of a central angle of a circle that intercepts an arc equal to the length of the radius. So here's your arc right here. Central angle just means like literally the vertex is in the center of the circle, and we go from there. So just eyeballing it here, and we're really eyeballing it, but 1 radian, notice I didn't say 1 pi radian, I just said 1 radian, is approximately 60 degrees. I think more accurately, it's more like 57-ish, but 60 gets you, a rough estimate. So everything we do for conversions is going to be based off of this fact right here, pi radians, which is, so about, 3.14 radians is equal to 180 degrees, or a semicircle. So if we're going to convert from degrees to radians, we're going to multiply those degrees by pi over 180. And vice versa, if we're going to convert from radians to degrees, we're going to multiply by 180 over pi. And we just got to try to keep those straight. So the other thing, the way I like to remember it is, whatever you're converting it to, those units are going to go on top. So if you're converting it to degrees, the 180 goes on top. Like we said, if you're converting to radians, that pi goes on top. So whatever you want to convert it into is the unit that goes on top. Okay, so we're trying to convert these into radians. So we're going to multiply by pi over 180, which makes 150 pi over 180. And then as we reduce that, you'll notice 150 and 180 are both divisible by 30. So that's going to make 5 pi over 6. Bingo. All right, let's see. Multiply by pi over 180. That makes 300 pi over 180. They're both divisible by 60. So we're going to get 5 pi over 3. And then last but not least, let's see, multiply by pi over 180. So we get negative 270. If you recall, a negative angle is okay. It just means we rotate clockwise instead of counterclockwise. And in this case, everything's divisible by 90. So you're going to get negative 3 pi over 2. All right, let's flip the script a little bit and let's see if we can convert from radians to degrees. So since we want to convert it into degrees, we're going to multiply by 180 over pi. Now, this is really nice because we've got a pi up here in the numerator, which cancels this pi in the denominator. If you're doing this mentally, you could say 3 goes into 180 60 times. 2 times 60 makes 120. Of course, if you're probably using your calculator, then you don't have to worry about the, canceling the 3 and the 180. All right, let's multiply by, we want to convert to degrees, so the 180 goes on top. You could see how the pi's are going to cancel. 6 goes into 180 30 times. 7 times 30 makes 210. Bada bing, bada boom. Now, not every radian angle is going to be in terms of pi, but lucky for us, all of these are in terms of pi, which means these pi's are going to cancel out. Let's see, 4 goes into 180 45 times, and 3 times 45 makes 135. Okay. Again, I'm trying to go fast through some of these, the computation part anyway, and your calculator can totally take care of those for you if you don't want to do them in your head, of course. Okay, so we're going to draw it and label each angle in standard. All standard position means is, the vertex is centered here and the initial ray is right here. That's all that means. So pi over 4 is going to put us right here. So, and again, if you want to convert that to degrees, you'd get 45 degrees, and maybe that helps you a little bit. So that would be our theta right there. Let's see, these are bound to get a little harder. Again, 5 pi over 4 is a little bit trickier. So maybe you're thinking, hey, I'm going to multiply by 180 over pi. And I could see the pi's canceling, and I say 4 goes into there, 45. 5 times 45 makes 225, and that's going to be the midpoint of the third quadrant. So this angle right here is going to be your 5 pi over 4. They use the Greek letter alpha, so we'll just try to use the same letter. So it's not quite, it almost looks like it's going to be an infinity sign, but it doesn't close up there on the right-hand side. Oh, we've got beta equals negative 3 pi over 4. Converting this into degrees, you're going to get negative 135 degrees. Negative means, okay, we're going to start here again, but we're going to rotate clockwise. So going around the horn, let's see, negative 30, negative 45, negative 60, negative 90, negative 120, ding, 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 ding. Right there is negative 135. And I'll indicate the rotation direction, and that's my beta. So again, like you can visually see, negative 135 is equivalent or coterminal with positive 225. All right. If we didn't, if I didn't draw this sign right here, that you wouldn't know. They're like, well, if I don't know whether you rotated clockwise or counterclockwise, I'm like, okay, it's 225, But once we throw in that arrow, we know it's negative 135. Let's see, what else we got cooking here? Ooh, 9 pi over 4. Again, let's multiply by 180 over pi. Cancel the pi's, bada bing, bada boom. Oh my God, just a big bear. I'm thinking, let's see, 360. How about 405? I'm going to show you another cool way to do this one that maybe is appealing to you. So when I saw 9 pi over 4, I said, you know what? That's really 8 pi over 4 plus 1 pi over 4. Would you agree with that? You're thinking, why would you think of it like that? Well, 8 pi over 4 is 2 pi, so there's one rotation plus an extra pi over 4. So I knew I went around the horn once plus an additional pi over 4. So that's going to put my angle right there. Started here. So we went around the horn plus this, and that's going to be I think that's a gamma. I could be totally wrong on that. I'm a little rusty on my alphabet there. So anyway, hopefully we feel pretty good about converting these angles from degrees to radians and vice versa, and at just being able to visualize them and draw really nice pictures of them. All right, take it easy.